we can see you.
Excellent. Alright, in that case I can get us started. This is going to be a pretty brief introduction to functional programming. Functional programming is quite a big topic, and really this will hopefully just give you a little bit of insight into what it is and how to get started with it, really. Alright, so what makes functional programming functional? Well, I guess many people think that functional programming is an alternative to object-oriented programming, and that's not really strictly true. It's more of an alternative to imperative programming, and it kind of tries to be a bit more declarative and based in mathematics. But to sort of illustrate what that means, I've got a couple of examples here. So if you wanted to take an array and check the number of integers that were greater than 10, you would probably do something like this with imperative code. You just have a little running total, iterate over those integers, and then if there's one that's greater than 10, just increment the number and then return that at the end. So that's fine. It's a pretty simple example, pretty easy to understand, but if you look at a more functional example, you can see here we're doing the same thing, but we essentially filter the list we have by all the numbers that are greater than 10, and then we return its length. So it's a little bit shorter. I would probably say it's easier to read. It's definitely more declarative, and there's kind of no state or anything like that you need to maintain throughout that in your head. So that really kind of illustrates the different approaches, and one of the things that you'll see there is something called a higher order function, and that's really one of the bases for functional programming. Functional programming is really about getting an outcome of the program by applying functions to data, manipulating data and changing it. Whereas imperative programming is more about sort of changing state and mutating things to get to the right result. In the case of higher order functions, in functional programming, functions are just data. Like any other data, like a variable, they're no different, and that means that they can be used like data. So you can send a function to another function as an argument. And when you do that, that is a higher order function. Now, if you've been doing JavaScript, this won't be new. You'll see this code everywhere. I would probably say if you're coming from a more Java background, then it will be less familiar. Java 8 added support for lambdas, so you can do this type of thing, but it's not something that you always see coming from the Java world. So with a map example, if we wanted to square root sort of all the values in an array, again, with some imperative code, we would iterate over that array, do the square root, put the value back in the array, and then just return the values. With functional code, we can use a higher order function here, and what we can do is use something called map, where you're essentially mapping the values in the array to a new array, and you do that with this higher order function here. So everything gets square rooted. And there is also a kind of subtle difference in between the two implementations there. The imperative code actually mutated the array it was given, so if any other parts of the code had that reference to that array, they would soon find that the data inside of it had changed. And with the functional example here, we're actually mapping the sort of values to a new array, and you kind of avoid that problem. When you do have things like that, that's known as like a side effect, and really that leads to sort of unintended consequences. So functional programming has the idea of pure functions, and pretty much a pure function is one that does not have any side effects. It doesn't impact anything outside the scope of itself. It's basically given some arguments and it returns a value, and it doesn't mutate anything, it doesn't rely on state outside of that. And these functions are actually kind of useful because they're really easy to reason about when you have pure functions. So one of the I guess cool things that you can do when you are dealing with pure functions is use a branch of mathematics known as category theory. And certainly, again, I'm not an expert in category theory, I'm not a mathematician, but you'll probably find there's some kind of good books on, I think category theory for programmers is one of them. And it's a really big area, but to just show you sort of one of the cool things you can do, if I move my face, there we go. Category theory essentially says that if I have a function f, and that function maps x to y, so it takes in x, returns y, and I have a function g that takes y and returns z, then I can actually combine these functions here, g and f, to map directly from x to z. And so that's kind of a pretty simple concept, but we can do some cool things with that, and one of those things is functional composition. Okay, so the simplest way of composing functions, again these examples are JavaScript, but it's the same for any language, is you literally just apply them one after the other. In this case we've got a list of numbers, we want to filter the even ones out, and then we'll square root those, and then we'll count the number that are greater than 10 on there. This approach is fine, but it quickly becomes quite unwieldy and difficult to read if you have a large number of functions that you want to apply to data. So what we can actually do is use our knowledge of category theory to say, well, if these are all pure functions, we can actually combine these functions to make a new function that will go directly from this input to the desired output. And again, that looks something like this. We compose our functions together, and then I'll move my face over here again. We are given a sort of new function here, which is concisely called num even and square root greater than 10. Perhaps that's a bit of a contrived example, but we get a new function here, and we can just apply that directly. So it's very much the same thing that we saw in that diagram, where we're just combining a series of functions together to get the desired outcome. This is sometimes called a pipeline, and it's such a common pattern in JavaScript that the TC39 people are adding a pipeline operator, which I'll come to next. The implementation of compose is probably a bit much to go over all in one go, but you can see here that this compose function we've created, it takes a list of functions, which is what we have here, and it returns you a new function that when you give it an argument, it will apply every function it was given and pass the result on to the previous one. And this is using a technique called reduce. Reduce is another thing that's quite common in functional programming, and you can think of that as an abstraction around iteration, or like for loops. It's a more functional way of doing for loops. We use higher order functions again, and you keep track of the last result of the iteration and the current item you're iterating on, and then you do whatever it is you're going to do in that iteration and return the value. So in our case, we've got this list of functions, and we're stepping through, and we're applying this one and returning the result, then we move on to the next one, apply the result, and continue like that until it gets to the end. I've used reduce right specifically because I want to go through the list in this order rather than sort of from the bottom up. So that's a little bit on reduce. Like I said, you probably don't need to worry about the implementation of that too much. It's just kind of nice to highlight that these things are pretty concise and simple. And so I mentioned earlier that I think the standards body for JavaScript is now called TC39, and there's a stage 1 proposal here to add a pipeline operator that does something really quite similar. We take the values that we start with, And you can think of it as, first of all, we pipe it into this function, and then that function, and then this one. And, you know, it's just a nice bit of syntactic sugar that makes things nice and easy to read. The only thing I would say is that these examples here are quite contrived and quite simple. In our case here, every step of the way, we've got one input and one output of our functions. So, you know, it's really easy just to pipe these things all together. But in the real world, your functions, there may be multiple arguments and things like that, and it might not be so easy to wire things together. So if you're doing that in a functional sense, you would use partial application of a function via something called currying. And essentially what you want to do is apply some of the arguments to a function and sort of get a sort of pre-baked function that's sort of half ready to go, and then use that later on. In this example, we've got a function here where we can add a number to every number in an array. So we've got that list of numbers we had earlier, and let's say we want to add 100. So we've got a curry function here, and we pass it our function, and we say we want you to partially apply 100 so that that parameter is already bound to this function. And then we get returned a new function called add 100 to all. Again, this is a very, very common pattern in the functional world, is you give a function, and then you'll get a function back, and everything is functions. But, you know, it does actually make it quite easy to read, because you give these things sensible names, and you can go from there. So now we've got this add 100 to all function, we can then directly pipe that in to our pipeline that we had earlier, and you know, it will work because there's only a single remaining argument left on this function here, the numbers. So there we go, we partially applied 100 to this function here, and when we put it into our pipeline, our final argument gets added and we get to the correct result. And again, the implementation of curry is really much simpler than you might expect. You have a function that's going to take a function, in this case add to all, and some arguments that you want to pre-apply. I believe I should probably put some ... dots there in case you want to apply many. And you're going to return a new function that's going to take the remaining arguments that haven't been applied, and then that will call the function with the first round of arguments and the second round of arguments. And that's really it for currying. But these simple techniques really give you an idea of how functional programming differs mentally from imperative programming, and even, you know, I said it's not a direct alternative to object-oriented programming, but it's true that when you are doing functional programming, you don't necessarily need to have objects and classes and things like that. So there are some languages that blend both. Scala is probably the most notable. JavaScript, again, is just a bit of everything. In JavaScript there is no discernible style, you just sort of can do whatever you want. And but in a lot of classical functional programming languages like Haskell, you only have functions. And rather than building hierarchies of classes and things that do things, you tend to structure it more as you have some data that's coming in and it needs to be manipulated and changed in some way and then output. And you know, that's more true in some situations, like algorithms suit functional programming very, very well, and there's some things that perhaps don't suit functional programming as well. Cool, so there we go. That is a super quick, ultra rapid introduction to functional programming. Although it was very quick, we covered higher order functions, pure functions, category theory, composition, currying. No, we didn't do monads. I promise I will do an explanation of monads one day, just because that's always a nice challenge. There's a blog post that sort of accompanies this this video, and it really probably repeats a lot of what I've said, but you know, if you prefer reading it and you want to have a look at those code examples, it's all on there. Yeah, okay, so I think over to you guys if there are any questions or anything I've failed to cover.
I've got a question on it.
Yep.
But that was really interesting, by the way. I had no idea what functional programming was. But I was just wondering if is a promise part of functional programming? That's just like
That's a good question. A promise is not strictly part of functional programming, but it's definitely influenced by functional programming. Now, one of the kind of classical difficult to solve problems with functional programming is side effects and how to deal with things that go wrong. You know, in this case we talked about pure functions, and we talked about, you know, only having a single input and a single output and that type of thing. But obviously there are some cases where you reach outside the scope of your program and things become unreliable. So file system access is a common example. When you do that kind of file system access, you might get a result, you might not get a result, you might get a failure of some kind, and so the functional approach to this is to use monads that I referenced earlier. And a monad, there's several examples of them, but my sort of 10-second explanation of them is a monad is something that wraps a value. And so if you call a function and you're expecting a value back, but for some reason, you know, you might get a result or you might not get a result, or in the case coming back to promises, you might get a result but it just will be in the future, for instance. Then you kind of wrap it in this package that says you're going to get this thing, but you either have to wait for it or you have to check that it succeeded. And so yes, promises are influenced by monads in that you can kind of access the thing that's inside of them, but strictly speaking they don't do all the things that a monad should do. So they're not really they're not as functional as they could be, basically.
okay, I think I need to know more on that.
Yeah, I mean, I guess I'll probably expand on that explanation a little bit. I guess there are quite a number of examples of monads. If you're coming from the Java world, you'll probably be familiar now with, I think they use either, I think it's optional, they've got optional, that's what it is. And again, you kind of have a function and you do it, you know, you do your result, and you will either have an optional that has the value of the thing in it, or you get like a none back. And yeah, that's very similar to promises or futures in Scala, in that you do an operation and it turns out to be asynchronous. So you know, you've got to wait for it to actually happen. You're going to get the result, but it's just going to be in the future. And so a monad is essentially a kind of standardized way of packaging up values if it's kind of not immediately accessible for whatever reason. It's a design pattern, I would say, is probably the best way to describe it. I'm trying to think, there's a whole number of really good examples. Arrays are another classic example, but they kind of, maybe not the best example, even though they're very common, just because you know, you have an array of values and you can map the thing that's inside of them, and when you apply map to it, you know, you actually affect every item in the array. So any kind of wrapper around a value or values is a form of monad.
Yeah, I understand. Thank you,
That was a terrible explanation. Like I said, I'll prepare one next time.
look at it, it was really good.
Sorry?
I thought it was really good. I understood like vaguely the high level concept.
Cool.
About one.
Yeah, I mean, there are, funny enough, like I said, it became a bit of a meme because they're difficult to explain, and there are whole 45-minute long videos of people explaining them. I think Uncle Bob Martin's has got one, so I think someone like uses burrito as a analogy for a monad because it's a thing that sort of wraps something up. Probably gets a bit too abstract at that point.
Oh, sorry for hijacking this. Does anyone else have questions? I think there's just like me, the question on my pad.
Yeah, that's cool. So again, really, I think you don't necessarily have to understand all of the items that were kind of on that list in order to get started with functional programming. You just kind of do it, and then when you maybe get stuck somewhere, you'll probably research a little bit more into that area because each one of those areas we covered really has a lot to it in its own right. And yeah, this was just a really high level overview of that. So just get started with it, start doing stuff, and like I said, if you've been doing JavaScript, you will have been exposed to some of these ideas already.
Lannis, I have a question.
Yep.
I thought functional programming, it was the fact that it's pure functions means that if you change one function, it doesn't really affect everything else. But I feel that with composition functions, changing one function would affect everything else, wouldn't it?
So I guess if you have a pipeline, then yes, if you change your function and change the return value of that, it would impact the pipeline. But the idea of a pure function is that when you execute that function, it will only, the only things that are important to it are the arguments it receives and the return value it gives. So if the opposite example of that is, let's say you have a class and that class has some properties, you call a method on that class and it mutates some of the properties and changes some stuff. So that's not pure because you're essentially affecting the state of the application outside of the function. And yeah, that's when things become difficult to reason with, difficult to test. You kind of need to set up all of your dependencies in particular ways and get the program into the correct state. So yeah, it's just one of the nice kind of benefits of using pure functions is that they're very easy to test. It's all right. Yeah. So anything else on anything covered there?
Is there a place we could find this slides?
The slides, yeah, I will put them on this blog post that I've got on the screen and send them out to you guys as well. I think the blog post itself will probably be more useful than the slides, but I'll stick them both on anyway. Cool. Alright, in that case, I think we are all nice and finished.